Welcome to Zombies and Reinforcement Learning Part 13. In this video, we're going to go ahead and actually start building out the train.py. This is also where we're going to start to tie it all together. So we're probably going to run into all the places that we've messed something up, or I've put in a typo, or any of that fun stuff. So this is it. This is when we get to finally kick off the agent's training. So let's go ahead and create a train.py. And we'll also create a test.py. We'll need that a little bit later. Those two go together. And in train.py, we are going to go ahead and just get our imports in. So we're going to say from util import star. We're going to say from game import zombie shooter. From agent import agent, the agent we built previously. All right, we'll go ahead and we're going to set episodes. This is just going to be a whole bunch of parameters. So episodes will be equal to 10,000. Max episode steps will also be equal to 10,000. If you have any problems, you may want to lower this a little bit so that you can see, you might get some results that are, I don't want to say more consistent, but if your agent's getting stuck or something, maybe a lower value makes sense. I ended up increasing this as, you know, I built out the solution to just kind of let it play until the agent died each time. So we're going to go ahead and set total steps to 0 to start with. Step repeat. So how often do we want a new action to happen every time? We're going to set to 4. And then you don't have to do this, but something I did here is set max episode steps to max episode steps divided by step repeat. So basically, I wanted to be able to set the total number of game steps here, and then understanding that it's going to take 4 steps for every one that's input. So the actual max episode steps is 2,500 in this scenario. You could obviously just cut straight to it and make this number 2,500 and skip this. This helped me think about it in terms of actual steps taken divided by step repeat equals the target number of steps we're going to take. We're going to say batch size is equal to 64. Learning rate is going to be equal to 0.0001. Epsilon will start at 1. Min epsilon will be 0.1. Epsilon decay, and this is a number I found just by experimenting, but I laid it on 0.995. You can play around with it. Gamma will be equal to 0.99. Hidden layer size will be 1024. And we're going to do a dropout of 0.2. All right, now to go ahead and create the environment. So we're going to set a couple window height and here, let's put window width first. Window width and window height are both going to be equal to 1200 and then 800. Okay. And world width. And, oh, you know what? It's the syntax highlighting's off because I put a period there instead of a comma. That would do it. All right, so world width and world height will be equal to 1800 and 1200. So we're just making the world a little bigger than the window. And then we're going to go ahead and say FPS is equal to 60. This value should get overridden because of some of our other logic, but let's go ahead and use it. So zombie shooter, all right, window width equals window width. Okay, and window height is equal to window height. And let's just go down to the next line. We'll say world height equals world height, and world width equals world width. And you could have just coded these in to the agent, or to the game. I would prefer not to. I prefer to keep these things external. If you wanted to play with them, you know, change some of the variables, see how it reacts to different different parameters, different world sizes, all that good stuff. All right, so sound equals false, and then I don't think we need anything else. I think that's all we put in. All right. We are going to go ahead and put together our summary writer suffix, and this is something that you should really just play with based on your needs. These are all the variables that I ended up working with as I built this out. So I called it DQN LR equals learning rate, and then underscore HL equals hidden layer. And you can kind of start to see how I'm using this. And then batch size equals batch size. And we'll go ahead and throw in a dropout, what our dropout is. And again, there is no technical requirement here. This is just what's going to show up as the label for this training run after the date. So the reason we're putting this in is that you might want to experiment with different parameters. Like let's say you wanted to see how it worked with a hidden layer of 756 or 512. Well, you need something in that training run name to show you what parameters you ran it with. Or you need to do it in some other way. Print it out into a file, show it. You need some way to show what your params were as you were experimenting, because these things can take days to train. This agent, and we'll talk about it a little bit more later, but this agent could take 30, 40 hours to train. So if you're running experiments over the course of a week, or realistically, sometimes a couple of months, you need some kind of labeling that's going to tell you what those experiments were. All right, let's go ahead, and I'm just going to run this and see if we should at least get an environment. Yep, and it goes away. All right, that's what we're looking for. I would not have expected it to pop up though. Let's see. Let me see if I missed something in game. Oh, you know what? We do need to, let's go take a look at our game.py. Oh, that is game.py. Okay. So we've got human equals false is the default, and we've only, okay, I see what we missed here. So we're setting, if you pass in human, we are setting sound to false, which is, or sound to false if you say human equals false. But we're not doing anything else. So something we need to do here is we need to set os.environ. And I guess we need to come up here and import os. And we're doing this because we don't want it to actually display anything. We want it to, you know, basically just run in the background. So the fact that we got a pop-up there, and just in case you missed it, let me show you what I mean. Okay. So if we come over here and run train again, that pop-up, the window that came up, we don't actually want the game to pop up on the screen. If human equals false, do not display game. That's really what we're looking for. And in fact, in my original code base, it looks like I used render mode for this. So let's go ahead and actually fix it to do the same. So let's go back over to game, and we're going to play with this a little bit. Instead of human equals false, we are going to say render mode, and we're going to default it to human. And I'm using render mode because that's a little bit of more of a standard param for Gym. You'll see render mode in other places. So I'm just going to say, let's see, we'll get rid of that. And we are still going to use self.human down in the environment. I'm not going to take that variable away completely. What I'm going to do is say if render mode equals human, then we're going to say self.sound equals sound and self.human equals true. Okay. Else, if you pass in anything else, or we'll just say elif render mode is equal to RGB. So we'll say self.sound equals false, self.human equals false, and we'll go ahead and say os.environ, and here we're going to say SDL underscore video driver equals dummy. And this is just a Pygame thing that should basically turn off the video rendering. All right, that looks good. Let's do one more thing. Let's go ahead, again, just thinking about future environment use. Let's just go ahead and say else raise exception invalid video drive or invalid render mode. So what this should do is we should be able to pass in human or RGB or nothing, and if we pass in nothing or if we pass in something invalid, it should give us, so let's go ahead and do render mode equals stuff. Let's just go ahead and test that scenario out. All right, cool. So we got our invalid render mode. So now we should be able to see RGB. And let me just run it. Oh, we're still getting our pop-up. Why are we getting our pop-up? Let's see. This is definitely something we need to fix. Ah, I see the problem. Okay. So we're setting render mode down here and the SQL driver environment down here, but we're setting our Pygame init and mode and caption and all that way up here. So what we're going to do is I'm just going to cut these 9 lines here, and we're going to come up and put them right above Pygame init. So by the time we get down here, we should already have them set. Okay. All right, cool. So that time we did not get our pop-up, which is exactly what we expected. All right, let's go on with our training, with our train.py here. So this is going to be agent. We're going to declare our agent equals agent. We need to pass in an env. We're going to pass in our dropout equals dropout. Our hidden layer equals hidden layer. We'll go down to the next line here. Learning rate equals learning rate. Step repeat equals step repeat. And gamma equals gamma. Okay. And then finally, we're going to call agent.train. We already have our train method. Episodes equals episodes equals, let's see, what did we call it? We did call it episodes. Max episode steps equals max episode steps. Summary writer suffix equals summary writer suffix. And in fact, actually, no, we'll leave that alone. Batch size equals batch size. In the original code base, I had appended stage 1 or phase 1 because there were multiple phases, but then that ended up not being very useful. So epsilon equals epsilon. Epsilon decay equals epsilon decay. And then min epsilon equals min epsilon. All right. Moment of truth. It's probably going to crash. I'm sure there's a typo somewhere. Okay, so no crash, but lots and lots of output. And that is, oh, and then it died. Okay. Okay, let's go see why. So if I go look at game.py here, actually no, it's going to be agent.py, and let's take a look at the train method. So we did 4 episode in range episodes. So we got lots of, we got prints in here somewhere. So for context, this should have kicked off a training run that should take, 30 hours. It should not have returned in a few minutes. And that's what I'm confused about here. Okay, 4 episode in range episodes. That all looks fine. Done equals false. While not done and episode steps. Yep, that while loop looks good. I don't think we're doing any returns. Here, let's just look for the word return. Reward done, if memory. Yep, all that looks good. Epsilon, episode time. All right, well, let's go ahead and fix our print because that's probably going to be easier to figure out. Oh, I wonder. Print. Okay. What's the... Okay, so we're basically going to say if self.human. Actually, you know what? I don't even think we need these. I don't think they're useful in the console logs. So we will get rid of that. We will comment that out. We'll comment that out. Very useful when you're developing, but not now that we've, basically got an environment. setup. All right, let's try it again. I don't expect it to run longer. Okay, we're still getting that bullet launched. But where? Ah, bullet.py. Okay. Okay. We're saving bullet.py, and let's run it again. You'll notice here that we've got our memory printout of 15.26 gigs. That is what you should expect to see. But then we're not getting anything else. We're returning and closing. And I have a feeling it has something to do with game.py, like maybe we're closing Pygame. I'm going to pause the video for a moment and take a look at it and come back when I see what's wrong. All right, so I think I found it, or at least a possible cause here, something we need to change. So in game.py, under game over, right here we've got Pygame time wait, and then Pygame.quit and sys.exit. So what we need to do here is we just need to say, oh, let me find that again, game over. So instead of having these here, we can either remove them, or what I'll probably do is if self.human, then we want to do a wait. And we will go ahead and get rid of Pygame.quit. I'm just going to comment that out because there's no real reason we want to quit Pygame. We just want to keep it running. All right, so let's try train.py again. Okay, and it's running and not failing, but it should be running faster. So let's take a look. I have a feeling I know what's going on here. Clock.tick. Okay, no, that should be fine. Okay, the first episode was 38 seconds. Not horrible, but I would have expected it to end sooner. So let's go ahead. We have our models being printed out. Let's go ahead and write our test.py. And that should help us see what might be going on here. You know, maybe why we're seeing the results we are. And we'll just let that run in the meantime. That's fine. So let's go take a look, test.py, and we're actually going to copy some of these params from train.py. In fact, let's just go ahead and yank the entire All right, let's go ahead and pull the entire train.py over as a starting point because we'll need a lot of it. We will still need a lot of the params. We'll need the game imports. We're not going to rely on a test method. We're just going to code the entire thing out in here. So we will need, let's see. We've got that. Max episode steps can be as many as we want. That's fine. Episodes is fine. Okay, that looks good. In this case, we actually want render mode to be human now. And then we're going to say, let's see, we're going to go ahead and load our models. So we don't want agent.train. We want model 1 will be equal to ZombieNet. Oh, we may need to actually do some imports too. Let's see. Yes. So back up here, we are going to go ahead and say from model import ZombieNet, and we'll grab other things as we need them. So, and then really we can get rid of summary writer. And okay. So ZombieNet action dim equals env.actionspace.n. Hidden layer or hidden dim will equal hidden layer. Observation shape will equal observation, and we don't have observation shape in here. Let's go set that or get that. Hang on. All right, we're going to say observation info equals env.reset. Okay. And now we can come down here and say observation shape equals observation.shape. Okay, and then we'll send both of these to device. And we need to go ahead and define device. So device is going to be CUDA 0. If torch, not Tabor, let's see. We'll need to go ahead and import torch. Okay. So if torch.cuda.is available, else CPU. Okay. We can just paste model 1 to model 2. And then for both of these, remember we're not training now, we're testing. So we can say model 1 dot load the model, and file name equals models/dqn1.pt, and model 2 dot load the model, file name equals models/dqn2.pt. Set both models to eval, and model2.eval, and then we go ahead and get into our test loop. So we'll be setting, we've already got step repeat. We'll say for episode in range episodes. And while I'm thinking about it, let's go ahead and just set episodes to something reasonable. For testing, we probably just want 1. We probably don't want more, but I'm leaving the range in there in case you want to. Done is equal to false. Episode reward is equal to 0, starting out. State info is equal to env.reset. Episode steps. This should look very, very similar to our training loop. A little bit different, but similar. Let's see. Will be 0. All right, and then we want our time. So I'm going to say episode start time is going to be equal to time.time. Helps if I have an equals and also if I actually import time. So let's go grab that one as well. Let's see. Okay. So we've got our episode start time is equal to time.time while not done, and episode steps less than max episode steps. Then if random.random, we will need random here. Port random. And we actually do still want some randomness even in our trained model. So we're going to go ahead and say 0.05 as our epsilon, which means most of the time, 95% of the time, it should take an action based on the model, and the rest of the time it should still get some randomness in the environment. All right, so if random.random less than epsilon, then we want to go ahead and say action equals env.action space.sample. Else model1 q values equals model1.forward state.unsqueeze, and on the 0th axis, .2 device, and the 0th element. And then we're basically just going to do the same thing with model 2. Okay. Q values is going to be equal to torch.min of model1 q values and model 2 q values. And then action is going to be equal to torch.argmax. For q values, dim is equal to -1 here, and keep dim true. Okay, and then we're going to go ahead and say next state reward done truncated info equals env.step, action equals action, repeat equals step repeat. State is equal to next state. And we're not actually, so in the regular training loop, you would store all of this in a buffer and then you would set state equals next state. We could just put state here instead of next state. I am keeping it this way just to have it look like the training loop a little bit more closely. All right. Let's see, plus equals reward and episode steps, let's see, plus equals 1. Okay, and then outside of our while loop, we're going to just go ahead and set episode time equal to time.time minus episode start time. Print. And then really, this is going to look identical to the last 3 lines here. So let's come over here and I'm just gonna steal those. Okay, so let's run our test.py and see what's going on. Okay, so we've got some randomness. Right now, our agent clearly doesn't understand how to avoid zombies or what to do here. But what it does look like is that, you know, the agent's playing, it's able to interact with the environment in some way, and it's not just, you know, completely random, even though it's not playing, you know, well at this point. So this is, and it made it to level 2. That's not awful. All right, so at this point, we're in a place where we basically just need to let it train for a while, let it cook. You can see we're getting wildly divergent scores here. We're getting everything from -10 to -2 to, you know, 4 and 5. Something that's probably worth thinking about here is that -10, and by the way, it just finished with a score of 11. That's actually really good for how long it's been training. -10 here is actually not that bad. And the reason I'm saying that, so if the agent just sat there, if it did nothing at all, it would get a -5. Because it wouldn't have, you know, it would not have picked up health. It wouldn't have, it would have just sat there and waited for the zombies to come, and then that would have gotten, you know, -5 lives taken, and then have it fall over. A -10 implies that it actually stayed alive a little while, collected some health, took some hits, you know, etc. So, and then what's interesting here is it's not ending. We're not getting a done signal. Now that might be a bug. That might be something that we need to look at. So next state reward done truncated info. Yeah, because it threw the "you died" and then the agent's continuing to leave. So or run around, you know, move a little bit. So that might be why we're taking 40 seconds and getting larger negative values. All right, let's dig into that. So if we go over to game.py, I'm going to go look at my original code base and see what we're doing with the done variable. Okay, so if done break, that's fine. Reward done truncated is coming from self.step. Let's go. Okay, so we're in reset. We're setting self.done to false. That's fine. And then what we should be saying, yep, if self.level greater than 3, then self.done is 2. So basically, if you succeed, you're done. But we should also be setting this in game over. So let's see if we are, because we probably aren't. Okay, that's reset. Where was game over? Yep, and that is accurate. Nowhere in here are we setting self.done. All right, so let's just come up here and say self.done is equal to true. And this is why testing is important. If you're not able to see what's going on, in the middle of training, you might miss that something like that, something just nothing to do with RL, just very obvious in the environment, is causing problems. So we've saved this. Let's go run our test.py and see if it successfully goes away once it finishes. It would be helpful in this phase if it was doing worse. All right, good. Our character's trapped. The zombies are coming. We just need her to hit a health of 0. All right. So it did successfully end, in that case, after 50 seconds. So what we're going to do, we're going to go ahead and Control-C this. I'm going to get rid of these two models. Move to trash, that's fine. And then what we should see is we should actually see these episodes take a lot less time. Okay, 32 seconds versus, yep, and then that one ended in 4 seconds after 379 steps. All right, so we are successfully stopping at the end. So let's go ahead and look at some of our stats. If you're using VS Code and you have the TensorBoard plugin, you can hit Control-Shift-P, and we're going to launch TensorBoard. If you don't have the TensorBoard plugin, you can just go install it. Or if you're not using VS Code at all, you can always just launch TensorBoard separately pointed at your runs directory. So we're going to look at scalars here. And this is what I was talking about with being able to see the various runs. This is every time we've run the code. I only want to see the latest because it's the only thing I care about right now. And what I'm interested in here is the score over time. You can also see, so the things we logged were loss, epsilon, and score. Some of these are self-explanatory. You obviously want score to go up over time. Loss can go up and down, and that's okay. You'll see, as the agent explores the environment a little bit more, you're going to see loss, change. But it could wobble. It could go up for a while. It should drop back down. The areas that I would be concerned about are if loss does nothing but go up, or if loss is nice and low, but despite loss being nice and low, the agent is not learning or not doing better. That would be something, I've seen scenarios where loss is super close to 0, but the agent is not actually doing anything useful. And then you will likely see a change in performance once epsilon decays. So like right now, we're getting scores of 5 and 7, and hey, looks great, right? But also epsilon is still 0.96 basically. So sure, the scores are great, but also the scores are going to be great because, or not great, but they're at least going to score occasionally because the agent's basically just doing random things. It's wandering around and shooting at things, you know, randomly, and yeah, that's actually not a horrible strategy. Randomness will get you right about this for scores. So what you should expect to see is you know, decent scores for a while it's mostly random. You'll actually see the scores tank once it gets down to a lower epsilon, and then they should slowly start to climb. If you don't have a PC that can run, you know, has enough memory, or you don't have, you know, either you don't have the memory, you don't have the GPU for it, or maybe you just, you know, don't want to tie up your desktop for 20-30 hours. I can recommend a service called Runpod. There are other things that do this. Just look for GPU hosting. Runpod is what I personally use in order to go and run this remotely. I have another video on how to set that up, and I will drop a link in the description. And I think this is probably a really good time to pause. I'm going to walk away and let this run for a while and just make sure that training continues. And then I will resume the video and we'll see how it did. So see you instantly for you and in a few hours for me. All right, I'm back, and let's take a look at how the agent is doing now. So you'll notice that we trained for about 800 iterations, and if you're still in sort of the default smoothing level, this just looks like noise. If you slide it all the way over here, though, you can see that what's really happening is it is slowly trending upwards over time, which is what we want to see. It's not going to learn really, really quickly, but we are moving in an upwards direction. So let's compare that to my original project. I'm actually going to pull that over. I screenshotted the performance at the time. So this was the first training run, and you'll notice that we got really, really slow training speeds, you know, up to about 1,500 episodes. And then after that first, you know, 1,500 episodes, it really started to take off, and then peaked after when we got to, you know, somewhere over 3,500 was right around where it peaked. So that's kind of what you can expect here. I'm happy with seeing that it is training, it's learning. I'm not going to retrain the entire thing on the video because, again, it takes about 30 hours to do. And I really don't want to wait 30 hours to finish and post this video. I'm going to try to get it out today. So, but it's learning, it's training. You can expect within, you know, however long 3,500 iterations takes for you. That's about what you're going to take to get to peak performance. But let's see how it's doing at the 800 mark. That's the cool thing about having a separate test.py, is we can test it as it goes. And you always want to look down here. The reason we have logging on loading weights from the weights file is to see if it actually loaded, and in this case it did. So it's not doing badly. It's wandering around. It has successfully shot a few zombies. It at least seems to have some understanding that it needs to stay away from them, and that it needs to shoot at them, even though it's not doing either very well yet. All right, and we landed with a score of -3. Just for comparison, let's go take a look at the original and rerun the test.py. And this is a trained agent. It's still very spastic, but and you'll see this one is, you know, wandering around and getting rid of zombies quite competently. So this is where you can expect to get to, or at least where I got to. So what are your next steps? Well, you know, a couple things you could do with this information. This whole course was on, our whole video series was on building a custom gym environment and what you could do with that custom gym environment. So things you could do next to really cement the knowledge in would be to create your own game and turn it into a gym environment, and then, you know, train an AI agent on it. That would be a really cool, you know, way to pick this up and run with it. You could take, you know, the current gym environment that we just built, and you could implement another algorithm to play it. You know, maybe, you know, for the discrete action space, you know, so what I used here was Q-learning. You could change it to a different action space and implement another algorithm. You could, you know, think of some way to take this and make it your own. You know, this was a zombie game. Can you turn it into a space game or a whatever you want to make it? And that to me is a really good way to take something like this where, you know, hopefully you've learned something going through the walkthroughs, but you haven't had to take the knowledge and build something with it yet. So taking my code and doing something new with it is going to be a really good way to go from someone who's typed it all out and made it work and maybe done some troubleshooting to someone who really deeply understands it and can go and implement this from scratch on something else. A word on code reuse. You are more than welcome to use my code. You can repost it, you can talk about it. I would appreciate you attributing it back to me, should you choose to. In the video description, you will find a link to my Runpod video. If you want to train on Runpod, you'll also find a link to Discord. If you are interested in talking about these projects. And then I'll also link to a completed GitHub repo with all of the code. If you know, I would encourage you, if you run into any bugs or issues, to spend as much time as you can just hacking away at it and getting it working yourself. But if you hit a wall that you can't get around, you are welcome to go and look at the GitHub. Or if you just want to download it and confirm it works, that is out there for your use. And then, yeah, this is the end of the project. We've built it. I hope you've had a lot of fun. I had a lot of fun creating this and putting together the series. If you like what you're seeing and you know, are interested in watching more reinforcement learning content or robotics content or other, you know, sort of start to finish build videos, please hit subscribe. I will continue to post these things as long as I find them fun and interesting. So with that, I will say goodbye until the next project, and see you there.